initial current okay. In this case, again we have an RL circuit, and the current, because the notation that the polarity that we chose for output current is from left to right, but now current is going in the opposite direction, so it's going to be actually negative. So it's going to start from here going negative up to this point, and in this case VO it's going to be 0. Okay, and once you open this switch, what happens here, again we have an RL circuit, but we have two sources. Now the current is still going to be negative, but it's gonna decrease like this, in the negative. Like when I mean decreasing, like I mean its negativity, it's gonna decrease, right? And this keeps going. Okay. And over here, the output voltage when switch is on, when switch is off, output voltage, it's gonna be the same as our VS. And this again will keep going. Okay, so as you can see here, the voltage or average voltage is positive, but the current is negative, right? So if you multiply them, this is going to be negative as well. So this means that electric power is going to be negative. It means that here we are in the, again you can see that here I is negative but voltage is positive, so here we're going to be operating in the second quadrant, and this is going to be called forward regenerative braking. Why is it called regenerative braking? It basically, the reason behind it is, in this case omega is still positive, but the torque is in the opposite direction. So it basically means that we are slowing down the motor. Okay, we are slowing down the motor. There is some energy that's gonna be charging our source, so that's why it's called regenerative braking. Basically the energy goes from the load to the source. The mechanical energy of the load, the mechanical energy comes from reducing the speed, right? So like there was some momentum, so like some energy stored in the running motor. Now when you're slowing down, the difference between that, it's going to be released into the source. So like it goes, the energy goes from load to the source. So the second quadrant, it's called also forward regenerative braking. It means that the motor is still running in the, let's say, clockwise direction, but the torque is in the opposite direction. In this case it was both were in the same direction, omega and tau. Okay, and I'm sorry, I'm making thinking mechanical points counterclockwise rotation direction is considered positive. So this is positive and torque is negative. I'm sorry about that. So here both omega and tau are in the same direction, but here omega is in the counterclockwise and tau is in the opposite direction. So in the class B chopper, energy always goes from load to the source, right? And it basically means that the machine is running in the generator mode and it's trying to slow down, and the energy that was stored in terms of mechanical energy in the machine is released into the source in the form of electric energy. So that was class B chopper. Class A chopper and class B chopper, both of them only operate in one quadrant. Class A only operates in the first quadrant. Class B operates in the second quadrant. Now, the next class that we want to see is class C. Class C chopper is a two-quadrant chopper. It operates in two quadrants. Let's see how the circuit looks like. So this is class C, which is gonna be two-quadrant chopper, and it's gonna operate in first and second quadrant, and it looks like this. Let me just do it like this. There's a switch here, there's another switch here, goes here. This is our L and E. Doesn't matter, you can include this one. Actually, I should do it like the same way that I did before, so let's just like do it like this. Let's call this one S1, this one S2, this is D1, and this is D2. So we have two switches and two diodes. And so let's see, first of all, as you have seen in the rectifier and inverter, and also like in other power electronic concepts, we never would like to have these two switches on at the same time, because if these two switches are both on, it means that we're gonna have a short circuit over the voltage source, right? So that's not desirable. Now let's see how the circuit looks like based on the status of S1 on and S2 off, and S1 off and S2 on. Okay, in this case, we would have, if S1 is on, we would have something like this. Okay, and if S2 is on, then we would have you also